Hi everyone, Heapified here, and welcome to video 3.1 of my Kubernetes series. The first thing I wanted to cover was the syntax of the YAML files that we wrote in the previous video. I also wanted to go over how I knew which exact fields and what values to put in these YAML files so that Kubernetes would recognize the objects I was creating. So later on in this video, we'll take a look at the Kubernetes documentation and see how you can find out what fields are necessary for your Kubernetes objects to work, without having to rely on someone to tell you which exact fields you need. So let's get started. So here I have opened the deployment YAML file that we wrote in the previous video. I want to just annotate this briefly with the different objects that are in the file. So as you can probably tell, YAML is composed of a bunch of nested objects based on indentation. In YAML, each set of fields is associated with an object. In this case, the fields API version, kind, metadata, and spec are all associated with an object. In this case, it's a deployment object. Now, metadata internally is its own object, and this object we've provided the name of express deployment. Spec is its own object as well. In this case, the spec object has 3 replicas, a selector, which is composed of its own nested object, and a template, which is another nested object. In turn, the template object contains a metadata and a spec field, which each also contain nested objects. Now, I'm going to go look at the Kubernetes documentation and annotate the sort of types of these fields. Now, the YAML doesn't have built-in types, but when we pass this object to the Kubernetes API server, the Kubernetes API will recognize each object as a certain type of object in its API. So let's take a look at the API documentation now. So I've pulled up the API documentation for Kubernetes version 1.14. As you can see, there's a ton of information here and a bunch of objects you can see on the left-hand side. Let's briefly look at the home page though. So we see here under resource categories, there's a field of workloads, which are objects we use to run containers in the cluster. In our case, this will be things like pods or deployments. There's also service discovery and load balancing resources, such as services that we'll get to later on. Some of the more advanced topics that we haven't yet covered include config and storage. So these objects will enable us to do things like store persistent data or manage things like API keys that we may not want to put directly in our application code. The cluster resource category is typically not used when we're developing the Kubernetes application, but when we put an application into production, people who are operating the cluster will be more interested in these objects. Next, and finally, metadata is another object that we've seen before that allows us to specify certain fields of Kubernetes objects. We won't get too much into that in this video. Feel free to check out the API on your own, especially if you're interested in learning how some of the more advanced features like config and persistent storage work. As you can see, there's a ton of information and full descriptions of each of the objects. In this case, since I've written a deployment already, I want to look at the API documentation for the deployment and see how it corresponds to the YAML file we've written. So I'm just going to go to the deployment object. Now, if you want a tangible example, you can just open up the kubectl example, and it'll give you a YAML file that serves as a sort of template example. Now let's look at what this first line here means. There's a group, version, and kind. These specify kind of the root fields of the Kubernetes object. Here, the API version corresponds to apps, the apps group version v1. So for our API version, we're writing down apps/v1. There are also other API versions, as this message points out, so we could have written things like extensions/v1 beta1, and so on. You can look here for the details. Now, the fields required here are API version, kind, metadata, spec, and status. Now, the status field isn't required for creating a deployment, but it is a field that we can see is associated with the deployment object. So, for example, I can perform reads against the deployment status, and I'll get back a deployment status object. If you click on this link, you'll be able to see what fields you get when you try to query for the status of a deployment. So let's take a look first at the deployment spec, since that's really the meat of the deployment object. If I click here, it takes me to the deployment spec in the apps/v1 group. The first field is min ready seconds, which tells us the number of seconds the deployment will check that a pod has not crashed before it counts the pod as ready for being in the deployment. You can read the full description here. I won't go through all of these fields, but I'll go over the ones that are most important and match them up to what we have here. So first, let's just write down that the spec is a deployment spec object in Kubernetes. And then we see that the replicas field is one that we've matched up here. So here we've set replicas to 3. What this means is that we want 3 desired pods at all times. The default, as you can see here, is 1. There's also a revision history limit and a selector, strategy, and template. We've included a selector, however I won't get too much into that in this section, but here we can see that there's a template that specifies what template the pods will come from when we try to create a pod under this deployment. So let's click on this object now and see what it contains. So here, let me just annotate that this is a pod template spec. Sorry, the template is a pod template spec. And it has two fields, a metadata and a spec. The metadata is an object metadata object. The spec is a pod spec object. So we've seen familiar metadata with labeling the pod as app backend. I'll note that these labels can be anything you want. You don't need to specifically use the app label. You just need to make sure the labels on your pod match the selector in your deployment spec. So let's drill down into the pod spec now. There are a bunch of fields, but for now let's just focus on the one we have here, which is containers. So you can see here that containers is actually an array. So in our YAML file, we must make sure that we use the array syntax, even if we only have one object. So to specify an array in YAML, you simply put a hyphen followed by a space, and indented, you put the fields of the object. So in this case, all of this represents one container object. If I wanted to have a second container, I would put another dash aligned with the same indentation as the first dash in the array, and then I could write here, for example, a name, an image, and so on. But for now, we won't do that. So let's click on container to see what the fields the container object contains. We can see that you can provide arguments to the entry point, and this will modify the command we wrote in the Docker file here. You can read this full description to see exactly how that works, but just know that these fields exist and that you can look at all of the fields that exist simply by reading the documentation. The ones we have here are name, since we must have, note that we have to provide a unique name for each container in the pod, and that we can't change this name. Another field we have is image, so this specifies the Docker image that we want to run in this container. I've also specified an image pull policy. This is not too important, but it just ensures that Kubernetes or Docker looks only at the local registry rather than online when I want to download the image onto a new Kubernetes pod. Let's look at finally the ports object. You can see that this is a container port array. Again, we've used the array syntax. And so in this case, this is an array of size 1 with one container port. So this is an array of container ports. And this is one container port object. Let's see what the container port contains. The container port expects a field called container port. This is a required field that must be a valid port number, of course. You can also provide it a host IP, a host port, name, and protocol. For protocol, we default to TCP, but you can also choose UDP, TCP, or SETP. Okay, so we've gone through the fields of our deployment object. Now let's take a look at our service. So for the service, I'm going to check out the service APIs and look at the service v1 core. Here, the group is core/v1 for the API version. The kind is a service, which we've specified. And then let's just drill down into the spec as usual. So the spec is of type service spec. If you have a cluster IP service, which all services internally will create, even if it's a node port or load balancer service, you can manually specify it here. If you don't specify it, then Kubernetes will assign it automatically. You can also provide external IP addresses, an external name for external name services, and so on. There are many fields here. You can look through them on your own time, but the one I'm interested in here is service port. So again, this is an array of ports. Now each port will map some external port for the service into a port on target pods. So this is the target port field. If I read the description here, it will say the number or name of the port to access on the pods targeted by the service. So when our service looks at a pod that it is abstracting away, it'll target the port specified by target port. Now we look at the port field. This is the port that the service exposes. So when we connect to the service, we have to connect to the service port, which in this case is port 8080. However, our request to port 8080 on the service will be transferred to port 3000 on target pods that the service selects. Now, the selector object is important for services because it specifies how the service can find ports to target. Unfortunately, the selector object doesn't have much description here, but just know that by specifying a key value pairs under the selector, you can provide the labels and values of those labels that you need every pod to have. Note that these requirements are typically ANDed together, so if you specify more than one label, the service will select only pods that have both labels with both values specified. Okay, so now I want to write a new object from scratch using the Kubernetes documentation. In this case, I want to create a pod that I'll run as a standalone pod rather than via a deployment. In real life, you'd probably never create a pod by itself. You'd usually use a deployment, even if you only wanted to create one pod. But for the sake of an exercise, let's just create a pod manually using the Kubernetes documentation. So let's create a new file. We'll call it pod.yaml. And I'm going to look up the documentation for a pod. Again, it's recommended that we only create pods through a controller. Controller could be a deployment or a job or stateful set, as this message points out. But in this case, we're just going to do it manually. So for the API version, we'll just do v1 because that's what the documentation says. The kind is a pod, as we can see here. The metadata, I'm just going to provide this pod with a name. We'll call it standalone backend. And then I need to provide it a spec. So the spec is a object of type pod spec. So let's look at the documentation for that. So I'm just reading through these fields. I'm looking to find the ones that I think are most important. Obviously the container field is important, so let's just write that quickly. So containers, this is an array, so I'm going to start by putting a hyphen. And then let's see what the containers need to contain. Okay, I'm just going to click on it over here. So we don't really need args here or a command because we've already specified those commands in the Docker file. Here I see I need an image because that's important. So image, I've already built the Docker image from the previous video and pushed it onto the local Docker registry associated with Minikube. So I'm just going to do that, use that image. So I called it express backend. So this will just use the Docker image that we wrote last time. Now you need to make sure that for your container objects you indent them so they're aligned, so that these two lines will be part of the same container object. I'm going to specify an image pull policy of never. Lifecycle I don't think I need. I'm going to specify a name. And I think I'll need ports also because my pod is using the internet. So let's add a ports field. This is an array, so I'm going to need to use the hyphen notation. This contains an array of container ports. The container port needs a container port field. In this case, our pod is listening on port 3000, so I'm going to give it a container port of 3000. I don't need a host IP, host port. I'll name the port HTTP. Again, I'm being careful to indent my lines so that these two lines are part of the same container port object. And then I'll break my indentation to go back to the container that I was specifying. Let's go back up to the container. Ports, readiness probe, resources, security context, standard input. I don't think we need any of this, so I think that's good. So let's try this out and try creating it in Kubernetes. I'm going to switch over to my terminal here. If I run kubectl get pods, you'll see that no resources are found. So let's just push this onto Kubernetes. So we'll do kubectl apply-f for file, k8/pod.yaml. Okay, and now if I can see that a standalone backend pod has been created. If I now run kubectl get pods, I can see that we have a standalone backend that's ready and it's running. Now, let me just show you a quick trick to get the logs output by a pod. This can be helpful in debugging. If you want to have your pods print to their standard input, you'll need a way to be able to see it on your terminal, even though those pods are running in a virtual machine. We can do this using the kubectl logs command. So the kubectl logs command, you type in the pod name, and then it'll give you the logs from that pod. Now, in cases where you have more than one container running on a pod, you also need to specify the name of the container you want to pull from. In this case, I've named my container express backend container. So by doing this, I get the logs associated with the container express backend container. Again, we don't need to do this because we only have one pod running, one container running on the pod. But if we had more than one container, this would be helpful. Alright, thanks for watching this video. In the next video we'll talk about services, load balancing, and the networking associated with them. Thanks for watching again. Heapified out.